everyone, and welcome to our lecture on Chapter 1 of our course textbook for our CIS 2131 class, Python Programming. My name is Professor Clark, and this week's chapter is kind of short and just an introductory chapter. So there's not a ton of slides this week. There's only like 9 slides in here. So very short, but I just, was going to go through a couple things with you guys before heading over to our lab lecture where we'll actually download Visual Studio Code and make sure the GitHub classroom environment is set up for all of you correctly, and you'll submit your first lab. But that'll be in the next lecture. So for this lecture, we're just going to talk about a couple of the things that are discussed in the reading for Chapter 1. I'd still highly recommend that you go and read the first chapter of the book. This lecture is not a substitute for reading the chapter. It is just a little supplemental thing where I'll kind of talk about a few things that maybe aren't in the chapter. And so we'll just move on to the next slide here. So what is a program? So a program is a set of instructions for a computer. And computers do exactly what we tell them to do. And programs are written to solve problems or to automate tasks. And I give an example here of a program. Though this is a short program, you could write this out in a Python file and run it. And it would be a very simple program, but what it would do is it would print out the statement, "Hello World." And this is sort of a beginner program that everybody usually writes for their first language or the first time they're learning a language. It's kind of just become tradition at this point. But so we'll do this later actually in our lab 1 exercise. But for now, you can take a look at it right here, and I'll walk you through the steps of doing all this a little bit later in the other lecture. But why learn programming? So programming is very useful, and it can be used for a variety of different things. I've listed out a few here. So programming is great for automating repetitive tasks. It is good for solving problems efficiently, analyzing data, building applications, tools, and games. Me specifically, my bachelor degree is in game software development. So this one applies to me a little bit more, or piques my interest a little bit more when it comes to learning programming. But maybe you want to learn programming because there's a certain type of application you like to build, or there's a certain type of tool that you like to build, or perhaps you're just trying to improve your logical and critical thinking, or you need to analyze some data, and learning programming is the easiest way to do that for you, right? So there's a multitude of reasons why we learn programming, and these are just a few of them. But why learn Python specifically, right? This course focuses on Python. So Python is easy to read and write. The whole philosophy behind building Python was creating a language that was as close to natural language as possible. So they made it very easy to read and to write. As a side note, for those who maybe have come from another programming language, like in the C family of languages, like C, C++, C#, Java, Python is very different in its syntax, and we'll talk about syntax in a little bit here, I believe. But basically, yeah, it's quite different from those languages, so don't get frustrated by the syntax when you realize it's very different if you're coming from one of those languages. And if you've never learned a programming language before and this is your first language, then disregard that. It doesn't matter. But Python is also used in many industries, and I've just listed a couple here just to put some ideas of some different industries that it's used in into your brain. So web development, data science, artificial intelligence, and automation all utilize Python. And Python also has a very large community and a multitude of libraries, so it really is just a great language to learn. Next, I just wanted to talk a little bit about how programmers think, just to get you thinking like a programmer before this course starts, but also just to keep these things in mind as we're going through the course and as we're beginning to learn more and more about the Python programming languages. So programmers break problems down into small steps. Um, they'll be precise and explicit. And also, this is a big one, expect errors, and debugging is normal. I'll talk about debugging a little bit more in the next slide. But yeah, expect errors when you're programming. It's not just beginners that get errors when they program. Professional programmers get errors all the time. Debugging is a normal thing when it comes to programming. You're never going to write the perfect program the first time that you write it. It doesn't matter if you've just started programming, if you've been programming for 5 years, if you've been programming for 50 years. No matter what, however long you've been programming, errors are going to happen and you're going to need to debug your program. So it's perfectly normal. So don't see it as failure that you can't write a program without errors. It's very, very normal. So do not beat yourself up about it. And another thing is that programmers learn by experimenting, right? So it's very easy to think of programming as, oh, I'll learn how to do it and look at what the textbook says, and after I read the textbook, I'll just know how to program because I know all the things that the programming language has to offer, right? You very much need to learn by experimenting and messing around with the programming language. You don't just write one or two programs and then suddenly you're an expert on the language. You really do have to mess around, even if it's not for an assignment. Maybe you just decide you're going to mess around and write a short program to do some sort of simple task just to see if you can do it. So I'd highly encourage experimenting with the programming language as we continue to learn it throughout the course. It'll be very helpful, and it will also help you to continually think like a programmer and become a lot more familiar with the Python programming language. So I mentioned the word debugging before. For those who don't know what debugging is finding and fixing errors, right? And errors are part of the process. I was saying that in the last slide, but again, I just want to emphasize it. Everybody has errors in their code. And I said it right here as well. Every programmer debugs, even professionals. And there's actually three different main types of errors, right? That you can get: syntax, logic, and runtime. I'm not going to go too in depth into them. In the book reading, actually, I'm going to pull this up right here. I actually have the book pulled up right here. If we scroll down a little bit, he talks about it in our course text. Yeah, right here. So when you're reading through, you'll see that he kind of goes into a little bit of depth about what each of these errors are. I'm not going to repeat what he says or read it out loud for you. You guys are able to read it yourself when you read the chapter. But I have included, because I'll make these slides available, I have included a little note here at the bottom. If you're just going through the slides and want like a reminder, or you haven't read the chapter yet, but you're just, going through the slides before the chapter, you can get a little idea right here. A syntax error usually means that you violated the grammar of the language, right? So syntax, our English language has syntax, and that's our grammar rules, right? Well, programming languages also have syntax, and that's the grammar of the programming language. So a syntax error means that you violated the grammar of the language, and these errors will be annoying, and you'll get them very often, and it'll just happen. These ones, they're also usually not too bad, because the wherever you're writing your code in will usually let you know with like a red squiggly line that there's a syntax error. So while they are annoying, they're a little bit easier to find and debug. Logic and runtime errors can be a lot more annoying. A logic error means that your program is running, right? So your syntax is correct, but you did the wrong thing, whether that's the order of your statements is wrong, or there's something wrong with your set of instructions. And that's what a logic error is. So the program will run, but the instructions are wrong, so it does the wrong thing. And then a runtime error basically means that your program runs and the sort of the steps that you've given the program are correct, but there's still a mistake in the program. And usually what this means is that you don't get the output that you expected from the program. So you'll deal with these a little bit more as you continue to program and as you continue to write bigger programs as we continue the course. You'll definitely run into each of these different types of errors, and don't let them beat you up. It can definitely be annoying when you run into an error, especially when it's something that's very obvious. I do it all the time. There's an obvious error that occurs when I'm writing a program and I just can't seem to figure out what it is. And I'm racking my brain trying to figure it out. And then, 10, 15 minutes goes by and I discover what the error is. And, it's satisfying, but you're also a little bit distraught about it because it took so long to find the error when it was right there the whole time. Like you missed a parentheses or something like that. So yeah, they can be annoying, but these are your different types of errors that you're going to run into throughout your programming journey. And I did want to briefly touch on programming languages. So humans use natural language. I used this phrase before, but humans use natural language and computers use machine language. And this is usually like binary, like ones and zeros, right? That's not very readable to humans. So programming languages basically bridge this gap from natural language to machine language. And some different examples of programming languages I've listed out here are Python, Java, C#, C++, JavaScript. There's many more besides these, but these are some of the more popular ones that I listed out right here. And since we are talking a little bit about some different programming languages that exist, I did want to touch on interpreters versus compilers as well. And I believe he discusses this in the chapter a little bit, so he may go into a bit more depth about it. But basically, Python is an interpreted language. And what this means is that the code is executed line by line, and it's easier to test and debug. Now, what a compiled language is like, C# is an example of a compiled language, and all of these C family languages are compiled languages. But basically what this means is that the code is compiled before being run, right? So, there's pros and cons to each, but just know that Python is an interpreted language for now, and that compiled languages exist, and this means that the code is compiled before actually being run. I kind of gave it a quick summary here at the bottom. Basically, compiled languages translate before running, and interpreted languages run directly. So that's really all for the slides. I know this lecture is sort of shorter, but chapter 1 is kind of just an introduction to what we're going to be going over and just an introduction to the Python language as a whole. So there's not a ton of meat here. But as we continue on into the next chapter, I believe the next chapter we go into variables. So that's where we kind of start diving deep into the Python programming languages, and we'll start to have, a little bit more substance throughout the week. But just some final thoughts for you guys. Programming is a skill, not a talent. So like all skills, it takes time to get good at, and that's okay. And also everyone struggles at first, and that's okay. So reach out to me if you need help with anything or you have any questions about anything. I'll do my best to answer them in a timely manner, and just make sure that you're understanding everything correctly. It's okay to struggle, and it's okay to ask me or someone else in the class questions if you need any help with anything. So just remember that as you begin this journey of learning Python. Persistence matters more than speed. It's more about persisting and just continuing to go at it, even if, at the beginning it's a real struggle, rather than just being quick to learn everything. It's okay if it's not quick to learn everything. It's okay if some concepts come a little slower than others. That's how we get better at things, and that's how we learn things. And you will get better the more that you practice. So just keep that in mind as you begin to learn Python. But that'll do it for our chapter 1 lecture here. And after this, you guys can go ahead and look at the lab 1 lecture. I'm going to go over what to do to install Visual Studio Code. I'm going to go over a little bit about how our assignments and labs and our programming projects, for the most part, are going to get submitted in our course. And yeah, so go ahead and go check that lecture out once you've read the chapter and finished watching this lecture. But I will see you guys in that lecture.